NASA's announcement on Wednesday marked an exciting moment for astronomers around the world, as the agency finally released long-awaited images of an interstellar comet, only the third object in recorded history known to originate from outside our solar system. The comet, officially designated 3I/Atlas, has drawn intense curiosity from scientists and space enthusiasts alike since its discovery in July. The newly released photographs show the celestial traveler as a bright point of light surrounded by a hazy, glowing halo formed by expanding gas and dust. Although the main body of the comet appears almost like a shining star from a distance, some images also reveal a faint tail stretching out behind it, a subtle but unmistakable indication of its icy material reacting to the heat and radiation of the sun. These images, captured between late September and mid-October by a range of NASA spacecraft positioned throughout the solar system, had been delayed in public release due to the government shutdown, which temporarily suspended operations within NASA and other federal agencies. Despite the simplicity of the images at first glance, their significance is extraordinary. Interstellar objects are exceedingly rare. Before the arrival of 3I/Atlas, only two such visitors had ever been confirmed. The strangely elongated Oumuamua, discovered in 2017, and Comet 2I/Borisov, identified in 2019. Each discovery has offered a fleeting glimpse into material formed around other stars, providing scientists with opportunities to examine cosmic fragments that were created far beyond the boundaries of our own solar neighborhood. With 3I/Atlas, researchers now have yet another chance to investigate an object shaped by environments and processes that could differ drastically from those that influenced the early formation of planets around our sun. The spacecraft involved in photographing 3I/Atlas include NASA's Punch satellites, designed to observe the outer atmosphere of the sun, the Solar and Heliospheric Observatory, known for constantly monitoring solar activity, the Mars-orbiting MAVEN mission, which studies the planet's upper atmosphere, and even the Perseverance rover, currently exploring the surface of Mars. The fact that such a diverse array of spacecraft, spread across different regions of the solar system, all participated in gathering data on this comet highlights just how valuable and rare this opportunity is. The varied perspectives help scientists build a comprehensive picture of the comet's structure, brightness, activity, and trajectory as it passes near the inner planets. Naturally, the discovery of an interstellar object has inspired not only scientific discussions, but also wild theories and imaginative speculation. Whenever a strange or unfamiliar object enters the solar system, rumors about extraterrestrial technology or alien spacecraft inevitably emerge. The case of 3I/Atlas has been no exception. Some online communities have suggested that the comet could be something artificial or intentionally sent. However, NASA officials addressed these claims directly during Wednesday's media briefing. Nikki Fox, Associate Administrator of NASA's Science Mission Directorate, emphasized that observations so far show nothing unusual. The object behaves exactly like a comet should, emitting gas and dust as it warms near the sun, and showing no signs of artificial structure or technology. She made it clear that there are no technosignatures, such as radio emissions or unusual patterns of motion, associated with it. Everything detected so far points to a natural interstellar comet, formed in the icy outskirts of a distant star system and released into space long ago. Yet the lack of artificial mystery does not make 3I/Atlas any less fascinating. On the contrary, its natural origin is what makes it scientifically precious. Because the comet is not from our solar system, it is essentially a preserved sample of conditions that existed in another part of the galaxy. Even tiny differences in its composition, the types of ices it contains, the way it sheds material, or the shape of its trajectory, can help scientists understand how other planetary systems form and evolve. Fox explained that these differences are exactly what excite researchers. A comet like 3I/Atlas could have been drifting through interstellar space for millions or even billions of years, making it older than our solar system itself. Studying it closely may allow scientists to compare the early chemistry of our solar system with the chemical fingerprints of another. In the coming weeks and months, astronomers expect to gather even more data as the comet becomes visible again after passing behind the Sun from Earth's point of view. 3I/Atlas reached its closest point to the Sun at the end of October, temporarily making it difficult for ground-based telescopes to observe. As it moves away from the Sun and reappears in the dark sky, researchers will be able to measure its brightness more precisely, analyze its speed, and study its spectrum, the breakdown of its light into colors, which reveals chemical composition. These observations could help determine whether the comet originated near a red dwarf star, a young star, or perhaps an ancient system with characteristics different from our own. They might even help scientists estimate how long the comet has been traveling through interstellar space. Tom Statler, NASA's lead scientist for solar system small bodies, explained that tracing the comet's exact origin is challenging. Interstellar objects wander through space for so long that gravitational nudges from stars, planets, and dense molecular clouds can gradually alter their paths. By the time they reach our solar system, their original route is often impossible to reconstruct. Still, with modern tools and careful measurements, scientists hope to narrow down the possibilities by analyzing its motion and comparing it with models of star systems in the region of the galaxy where the comet likely once lived. One of the most anticipated moments of the comet's journey will occur on December 19th, when 3I/Atlas makes its closest approach to Earth. Even at its nearest, the comet will remain at a safe distance of approximately 170 million miles, so there is no threat of impact. But this close pass will allow some of the world's most advanced observatories to capture high-resolution images and detailed spectra. The James Webb Space Telescope, known for its ability to study faint, distant objects with unprecedented clarity, is scheduled to observe the comet during this period. Ground-based telescopes, including the W.M. Keck Observatory in Hawaii, will also be gathering data. Each observatory has unique capabilities, and the combination of observations from space and Earth will provide scientists with one of the richest datasets ever collected for an interstellar comet. As scientists prepare for this next phase of observation, excitement in the astronomical community continues to grow. The study of interstellar objects is still in its early stages. Before 2017, no such object had ever been identified, and now researchers are learning to refine their methods quickly. With each interstellar visitor, they gain new insights into how common such objects may be, what they are made of, and how frequently they enter our solar system. These discoveries are slowly shaping a deeper understanding of the galaxy as a dynamic place filled with wandering fragments of countless star systems. For the public, the idea that a piece of another solar system is passing nearby captures the imagination. It reminds people that the universe is vast, full of mysteries, and constantly sending us unexpected surprises. Interstellar comets like 3I/Atlas are not just astronomical objects, they are cosmic messengers, carrying stories from distant regions of space, places we may never reach with spacecraft in our lifetimes. Their journeys reveal that the boundaries between star systems are not as isolated as they once seemed. Over millions of years, gravity likely nudges debris from one system into the empty spaces between stars, where it drifts silently until chance brings it close enough for scientists on Earth to see. As 3I/Atlas continues its passage through the inner solar system and eventually heads back out into the vastness of interstellar space, researchers will continue collecting every bit of information they can. Even small discoveries, a trace gas never before detected in a comet, a surprising change in brightness, or a unique shape in its tail, could refine scientific theories about the formation of stars and planets. This rare visitor serves as a reminder that the universe is still full of unknowns, and that each new observation adds to humanity's growing understanding of how our cosmic environment came to be. In the end, 3I/Atlas represents not just a scientific opportunity, but also a symbol of the ongoing quest to explore, observe, and learn about the universe beyond our home planet.